And welcome in a new video, and in this video we are going to understand about the process in detail, that how the process is basically look alike in a RAM or in a main memory. Okay, we will see the representation of a process in this video, and we will see one of the most important thing about the process, that till now what we understand is that this is our CPU, this is our CPU, and this is our main memory, this is our CPU, and this is our what main memory. Now what we understand is that program P1 and P2 are in our main memory, and operating system is the one who collect a P1 program and send P1 program to the CPU, and operating system collect the another program, or let's say P2, it send that program to CPU after completion of a P1. Now we understand it like this, but in reality this is not happen. Okay, this is not happen. What basically transfer to a CPU is not this program. There is a something called PCB, program descriptor, which is available in operating system by itself, and operating system collect it and send it to the CPU. We will see these thing and what that how it distribute the programs, and we will see this thing in the video. Okay, so first of all we understand about the process representation. Okay, so how the process is basically represented in our main memory. Okay, so now this is our, let's say this is our RAM, or you can say main memory. Okay, RAM or main memory. What's present in a main memory? Operating system and the programs. So let's say we have a program 1 or a process 1, 2 and P3. Okay, P3. So we have these things available in our main memory. We have 3 processes available in our main memory. Okay, so now we understand these things in detail. Now what basically present in this block, now understand this thing. Okay, so the program number 1, okay, let's understand this in detail, that what is present in this block. Okay, so this block in so in this block there are so many things which is present in this block. So what are the things which is present in this block? So the thing which is present in this block is basically, the first thing which present in this block is code. Code means the textual section. What does the mean of a textual section? Text section means like the program instruction. What does the meaning of program instruction? Means whatever the code you write, the raw code, the text form code is basically stored in a layer called code, or you can say a text section. Okay, means if you write a program in a Java, so whatever the thing you write, whatever the text you write, that text is basically stored in this code block. Okay, the text is basically stored in this code block. The next thing which is stored in this was a data section. Okay, the next block is a data section. What is present in this data section? This is a very important section as well, because in this section the global or a static variable is basically loaded. Global or static variable is present in this section. Let's take an example that what is a global variable or a static variable. Okay, so in C program you write everything in the main section. Okay, you write everything in a main section. Let's say we have a function called sum in this, which basically take 2 parameters a and b, and it return, or you can write it like this, it return not return. Okay, so what we are going to do is, here we define a new variable which is, let's say x is equal to 20, and it return a plus b plus x. Okay, let's see this thing in this way. Okay, so we have a function, a main function. In C program, if you know that everything is inside in a main function or in an executable form, means if you write anything in a main function, then only your code will be executed. Okay, and let's say int a is equal to 10 and int b is equal to 20. So the variable you define outside any function or inside only a main function, means a variable you define inside a main function only is called a global variable. These two variables are global variables. These two variables are global variables. So I hope you understand about the global variable, the variable we can use from anywhere inside a code. For example, if I have a function and then again a function and then again a function, but if I return a plus b, I will get the 30 as an output. Okay, so I hope you understand about a global variable, means we can use these variable from anywhere. If this function take a comma b and it return ab, so it definitely return 30. Okay, so ab is, but if you see this function ab is not defined, then also it return. In the above function ab is also not defined, then how is this function return the a plus b? So this is because a and b is a global variable, means those variable which define once in a function and use from everywhere is basically a global variable. And what is a static variable? Means you define it at once, but when you change the values that and you try to print that value, the initial value is printed. The initial value is printed means you change the value. That value can change any other function parameters, other function things, but if you print that particular variable, that will be the same variable. Okay, that value is not changed. So this is what a static variable. You will understand this thing. Try simply Google it. What is a global variable and a static variable? We understand this thing very clearly. But in short, this is what a global variable and a static variable. Okay, so global variables and static variables are stored in the section which is a data section. Okay, so a process contain these section. A process contain these section. Okay, a process contain these sections. Okay, now after the data section we have another thing which is called a heap. We have another section which is called heap. Now what is this heap? The heap is basically used for the dynamic memory allocation. Dynamic memory allocation. So what basically heap is used for? Heap is used for the dynamic memory allocation. Means if you simply create a memory in a program which is used after the compilation or when the program start executing, when you if you want to store the result in that memory, so so for that thing the heap is used. If you want to create a heap memory, means if you want to create a dynamic memory, so there are different ways. MATLAB is the one which you can create a memory of a particular size. Okay, so heap is used for the dynamic memory allocation. Okay, and the other block is called stack. The other block is called stack. Now what is an stack? Stack is basically used to store the local variables values, functions parameters, and it basically store the addresses of a resultant thing or a return it basically return addresses is also stored in the stack section. So what basically is stored in a stack section? These activation record is basically used in a stack section. So activation record is used. Activation record is basically stored in the stack section. So what is an activation record? Local variables, functions parameter, function parameter, okay, and the returning address, return address, and many more things. Basically stack is used to store. What is a local variables? In short, the local variables who is defined in a particular function is called a local variables. For example, in this case, x is a local variable. X is what? X is a local variable because it is defined in a particular function. This x is able to use in this sum function only. If I try to use this x outside this sum function, then I am unable to use this thing. So what are our local variables? We can use in local variables in a particular block, in a particular scope. The variable which is used in a particular scope is called a local variable, basically. Okay, so I hope you understand what is a local variable, and a and b is a function parameters, and what it return, that address is basically a returning address. Simple thing. Okay, so we understand about heap, we understand about the data section, understand about the code section, understand about the stack section. Now what is this block is used for? The block between the heap and the stack. So this block is used for, this is an extra space, this is an extra space used by the stack and used by the heap both. Okay, so this space is used by the stack and heap both, because in some program, for example, if stack memory is full, like for example in some program, the local variable, the functions, there are a lot of function, lot of local variables. So if a lot of function, lot of local variable is also possible, lot of returning address is also possible. If this stack space is full, if this stack space is full, so what stack do? Stack try to get the more space, so this part is used by the stack. So in some programs, if the global and static variables, in some part, if the dynamic memory allocations, means a dynamic memory is created a lot in some program, then heap is used the above section, then heap is used the above section. So I hope you understand about the stack and heap and the space between these two. Okay, so a program is basically contain these four sections. What are the sections? Stack, heap, data, and the code. So I hope it is understandable that what is these thing and how, what basically the section contain, these section contains. So you can write it like note so that you can remember, is that the process is stored in a main memory in a 4 section. So each process is stored in RAM is of 4 section, and what are these section? Stack, heap, data section, and a code section. Okay, so every process, P1 contain these 4 things, P2 contain these 4 things, P3 contain these 4 things. So every program basically contain these 4 things. So I hope it is understandable that what is the representation of a process. Okay, so this is about the representation. I hope it is understandable that what is how the process is basically represented. Okay, now the next thing is, what are the operations we can perform in a process? What are the operations we can perform in the process? So what are the operations that we can perform? So the operations, because we know that, okay, so program is goes in a CPU, so what are the things, what are the operations that there's now it goes in a CPU, so it's now become process. Okay, so what are the process that what are the operations on that process is basically going on? What are the operations in this process is basically going on? Okay, so so what are the operations? Operations like create. So now if a program in a main memory, let's say it's a P1 is a program. Now it's a program because it is in a main memory. Now it is in a non-executable form. Okay, when P1 start executing on P1 having an executable time, P1 is having an executable time, it now become a process. Okay, so now P1 process is basically created. So creation of a process is an operations. Creation of a process is an operation that is performed, or creation means that the resource like CPU is basically now P1 is basically having a CPU, means resource allocation. Resource allocation. So now resource is allocated to this particular process. Or what operation basically processes go through with? Schedule, or you can say run. Now what does this mean? This means that the process, if in an operating system there are more than one process, so definitely one process can go at a time, one process can get a CPU at a time. So how they select the process, how operating system select that process, that okay, so P1 is first of all go to the CPU, and then P2 will get a CPU. So how the scheduling of an process is going on? So that's called scheduler or a run, when operating system schedule this process. And how it schedule, we will see these things in an upcoming videos. There are so many things, FIFO, LIFO, round robin, there are a lot of things. So we will solve these questions as well in an upcoming video. Till now what you have to understand, that operating system schedule some process. Say operating system help the process to get a CPU, schedule a process to the CPU. So scheduling is one of the operations in a process basically go through with. After that we have another operation is what? Wait, or you can say block. What does this mean? This means that now CPU is having, let's say P1 is having a CPU. Okay, P1 need to do some input output operations. P1 need to do some input output operation. So how P1 able to do that input output operation? Means it first of all leave the CPU, it basically leave the CPU and perform its input output operation. This is the only case, because in a good operating system CPU cannot become idle. Okay, so what operating system do? It remove P1 and give the CPU to P2, give the CPU to P2. Till the input output operation, P1 have to wait, because it perform input output operation, so it have to wait, so that waiting section is what? That thing is called wait or a block. Okay, so this is one of the operation that process will go through with, processes go through. Another is what? Suspend or resume. Suspend or resume means if a process, if an high priority process is come, so the low priority process have to leave this, is definitely have to leave the CPU. For example, if P1 is a process, P2, let's say P2 is a process which is having a low priority as compared to P1. So when P1 is come and P1 say to the operating system, okay, so I need a CPU urgently. So definitely what operating system do? Operating system provide CPU to the P1 process, and P2 process is now leaving the CPU. Okay, after some time it resume their process, so that till then the section, the P2 process is basically Rn is a suspended or a resume. The state that P2 Rn is a suspended or a resume. There is a state diagram as well. We will see this thing in a next video, which is a very important thing. Then you understand these operations in detail. Okay, now the last one is what? Termination. What does the termination mean? Termination means now resource is deallocated. What is the meaning of a resource deallocated? Means now the CPU is because now the process is successfully completed. Termination means process is successfully completed. If the process is successfully completed, so it have to leave the CPU, because it's now this task is done, so definitely it have to leave the CPU, so it have to deallocate the resource. It have to deallocate the resource. So this is what the operation. We will see this thing in detail in an upcoming videos as well. So but till now you can understand it like this, that in this way these thing is basically done. Okay, we are moving towards the next operations. The next topic is now we are starting the most important thing, which is PCB. Now we are starting the most important thing, which is a PCB. Now what is a PCB? What is a PCB? Now what is a PCB? So PCB is nothing. PCB is just a program descriptor. PCB is called, sorry, process descriptor. PCB is called process descriptor. Why PCB is called a process descriptor? We will see this thing. Okay, so this basically a full form process descriptor. Okay, now what is a PCB and how this thing is performed, we will see this thing. Okay, so when so till now what we are understanding is that we have a CPU, okay, and we have a main memory, we have a CPU, and we have a main memory. In main memory we have an operating system, and we have a programs. Operating system come, collect a program and transfer this program to the CPU. Till now we understand it like this, but in reality this is not happen. In reality, the PCB, there is a term PCB, which is nothing, just hold everything about the process. PCB is nothing, just a description of a process. Is a description of a process. So for a P1 particular PCB, for a P2 so number of programs, number of PCB, number of programs is in a main memory, so number of PCB will be there. Okay, so P1 P2 is basically because 2 programs is in a main memory, so we required 2 PCB blocks. Okay, so now this having an executable time, so now it become a process basically. So how the operating system transferring this process to the CPU? How this operating system, what basically operating system do? So operating system, what it does is it collect the particular process and send that PCB of that particular process to the CPU. It send a particular process to the CPU. So I hope it is understand that what is basically operating system do. It send the PCB of a process of a P1 of a P2 to a CPU. Now what basically the PCB contain, what is written in this box, what is basically the operating system is stored. So this is what basically operating system is stored is. First of all is first and the main thing is PID. PID means the process ID. The process ID, or you can say unique ID of process. Unique ID of process. PID means unique ID of a process, because in a RAM there are numerous programs, numerous processes. So every process need to be discriminated uniquely, because every process perform different thing. Okay, so for example, P1 performing different thing, P2 performing different thing. So definitely we have to distinguish between these two things. Okay, so it will be distinguished by the process ID. Okay, so the next thing is PC. PC is what? PC is nothing called program counter. Program counter. Now what is a program counter? Program counter basically used to store the address of a next task. Program counter is stored the addresses of a next next task basically. Means if some other task is basically going to perform, so it hold the address of that particular task. Simple. Okay, so if you understand about 8085 architecture, then you understand about the general purpose register, the program counter, the accumulator, and a lot of things basically in 8085. If you understand about that thing, then it's easy to understand about a program counter. If not, then you have to just understand it that it is store the address of a next task. Simple. Other thing is general purpose register, GPR. What is it? General purpose register. What does this used for? So general purpose register is used to store some particular values in 80. For example, if I take about 8085 processor, so in this there is a general purpose register of 8-bit. Okay, so there are basically six types of register, B, C, D, and so on. Basically, it is, if you want to use in a pair, you can use in pair as well. But the basic function of a general purpose register is used to store the values, used to store the addresses. Okay, so these registers are used to store the particular thing, means whatever the operating system basically store in this general purpose register. So the operating system can able to store that important things in this registers. Simple. Okay, or what basically the PCB contain? PCB contain the list of devices. Now what does this mean? List of devices means that devices which is connected to a particular process. For example, if we talk about the P1, so what are the devices connected to a P1? For example, P1 process is like I'm recording this thing. Okay, so process is basically on the OBS Studio recording everything. So this is what one process is. Okay, so this process, the OBS Studio, I connect my mic, I connected my pen tablet, I basically whatever I do in a screen, everything is recorded by the process. So the number of devices which is connected to that particular process, like my mouse, like my pen tablet, like my mic, is basically the list of these things is given, is basically the list of these things is basically stored in this PCB as well. So whatever the connected devices for to a particular process, what device is basically connected, so we have to the operating system have to perform the list, and that list will be stored in a PCB. Okay, so list of devices is very important as well. Now after that, what basically we have to what basically is the PCB having a type as well. Type means what type of a process it is, because process is of numerous type, like foreground, background, system. Which kind of process is it? Because that kind for a particular process, the CPU have to perform some particular function. Okay, so that's why the type of a process is also important. So what kind of a process it is? Foreground, background, or a system process. So what kind of process is basically it is, what type of process is, we have to determine this thing as well. The process have to determine this thing as well. Operating system write that thing in a PCB. After that, we have to operating system have to determine the size, means in PCB the size of that process is also need to be mentioned. Size like 1 MB, 1 MB, 2 MB, 3 MB, whatever the size is, basically 1 MB, 2 MB, whatever the size. So the size of a process is also stored in this block, in the PCB process descriptor. Okay, and what basically the thing which is written in PCB is a memory limit, Memory limit means simply final minus initial means, for example, P1, what is this limit? This is called initial limit, this is called final limit, because process 1 take this much of space, this much of memory. So what is it initial limit, what is it final limit? We have to write this thing in the memory limit. Operating system is the one who determine the memory limit of a particular process in the PCB. Okay, or what basically having PCB, the priority. Now what does this mean? Priority means, for example, if P1 is more prioritized than P2, so what operating system do? Operating system collect the PCB of P2 and send that to a CPU. Now CPU is executing the P2 process. Okay, but after all of a sudden P1 process come and said to operating system, I am in urgent, I need to perform I need to execute. So what operating system do? Because P1 is highly prioritized than P2, so what operating system do? Operating system provide CPU to the P1 process. Now P2 have to leave the CPU. So this is what the meaning of a priority means. Which process is highly prioritized, that process will get a CPU first. We will see these things, that how we determine the priority, how operating system determine the priority, okay, in an upcoming videos. So priority you need to define. Priority is basically defined, and the state is also defined. State means like, now the processes will get the CPU. So if it perform input output operation, then process have to be in a waiting state. If it do input output operation. So operating system have to determine the have to determine that, okay, this process in this state, in a input output state, so I now can provide CPU to the other process. So this is also very important thing. Okay, so this is also very important thing about the state. We have to determine the PCB basically determine the state of the process, and the list of files is also okay. So list of files is also written in a block of a particular process. List of files means if I am using a process 1, means I am recording the videos. So is there any file which is open in a background? For example, if a PPT I open in a background, so that information is also written in this list of files. Okay, so I hope you understand about these things. These all are basically the attribute of a process. These all are things what? These all are the attributes of PC or attributes of processes. Okay, attributes of process. So these things are basically process contain. Okay, so the collection of these things is called PCB, process descriptor. Means the description of a process. Okay, so I hope you understand about the PCB as well, that what is a PCB. Okay, so what you have to remember, what point you have to be noted, that process does not go to the CPU. Process does not go to the CPU. What I told you, that process never go to the CPU. PCB of a particular process is basically go to a CPU. So CPU to what? To execute. PCB of that process goes to CPU. So I hope you understand this thing. And what you have to note as well, that PCB having all the attributes of a process. PCB having all the attributes of process. That thing means the list of these things is called PCB. So PCB what contain? PCB contain the attributes of a process. The all thing is called what? Attributes. So the collection of these attributes is called PCB. Simple. Okay. So we understand about PCB. This is a very important thing. You have to remember these things. Okay. Now there is a one more thing which is called context. What is context? The attributes, values. What does that mean? That means let's collect some attribute. Like if I collect state, priority, and the ID. Okay, so these basically the attributes. PID, let's say ID is 3 of a particular process. State, it is in a running state, and what basically I select is priority. So let's say its priority is 5. Okay, so what is the context? And we basically attributes are so many things. Okay, so in general, what is a context? Context is nothing. The result of these things is called context. Means 0, 3, running, 5, or whatever the values is called context. Remember this thing. This is context. Okay, this is context. There are one more thing which is called context switching as well, which is a different thing. Context is what? Context is basically the values. If I said PID is equal to 0, 3, it means it's a attribute. But when I said 0, 3 running 5, it means I talk about context. So I hope you understand about context as well. Okay, so what is the context? The context of PCB of a process are collectively known as the context of a process. You can say that the context of PCB of a process are collectively known as the context of the process. Simple thing. What basically I told. Okay, so this is what context is, and now what we understand is that about the priority as well. Priority means if I take one more process whose priority is 0, 1, so definitely this is highly prioritized process. Let's say it P2 and let's say it P1. So this process is a highly prioritized process. So if P1 is running and P2 come to run, so operating system provides CPU to P2 because it is highly prioritized. Simple. Okay, so the switching between the process, because initially this is what? CPU, and this is what? A main memory, or you can say a RAM. This is what an operating system is. P1 program, P2 program. Okay, P2 program, PCB of P1, PCB of P2. So if PCB of P1 is running in a CPU whose priority is 0, 5, so it is running. Now after some time PCB of P2 come, and so operating system check its priority. It says 0, 1, means highly prioritized. If its process is highly prioritized, then what operating system do? Operating system provide this PCB to the CPU. Now the CPU is executing P2 process. Okay, so you can see that how switching is taking place in this thing. Means first of all P1 process is running. After some time P2 leaves CPU, P1 leaves CPU, and P2 occur in a CPU. After some time, let's say the P3 process is also there in a main memory. So P2 leaves CPU, P3 is in a CPU. So you can see that switching of a process is taking place. Switching of process is basically taking place. So this switching of process is called context switching. This switching of a process is called context switching. So I hope you understand about the context switching as well, switching of a processes basically. So I hope you understand these things. Okay, so this is all about in this video. Thank you for watching this video. Like the video and subscribe my channel. Okay, so subscribe.